Hello everyone, and welcome to the video on machine learning classifications, where we go over the types of machine learning. There are three main or broad ways that we can classify machine learning models. First is how they are supervised during training, and in a second we'll go through all of these. The second is whether they learn through batch learning or online learning. And finally, they're categorized on how they refer to the training data for making predictions. So there's two types of that. There's instance-based and there's model-based. Going through the first classification, supervision. In the simplest terms, supervision is how much humans are directly involved in the process of training. So the process of training we refer to as observing or correcting predictions. So the more you're directly involved in the training of the algorithm, the more supervised your machine learning model is. So this is a spectrum. On one end of the spectrum is completely supervised machine learning programs. On the other end of the spectrum is unsupervised training. And then in between we have examples like semi-supervised and self-supervised. Each of these we're going to go through in future videos, but for now, just to understand the classification, it is important to know that there is a spectrum of supervised to unsupervised. The second classification of machine learning is called batch, is how it learns, so batch or online learning. Batch learning has one whole training session to produce one whole model. And if you would like to update the model with new data, you would have to repeat the whole training session. So update equals one whole training session with both the old data plus the new data. So that's a lot of data that's being covered every single time, and it takes a couple of hours depending on the size of your training set. And because it's so resource intensive, it's also just sometimes called offline training. The opposite of batch learning is called online learning. And this is a process of continuously feeding small amounts of, and this is very important, small amounts of new data into the system. What you are doing essentially is incremental learning. Every time you have some new data that you'd like the model to acknowledge, you add just that new data. And you can keep updating the system every single time instead of having to retrain everything based on both the old and new data. So this takes hours to do again. So batch learning takes hours. Online learning, you just take the new data and add it to the system. The main benefit of online learning is avoiding something called model rot. We need to understand that new data comes out regularly. New data comes out regularly. And we need to always be aware of this. Because if there is new data, that means there's old data, and that's what your program is trained on. This is also called a decay drift, by the way. Decay drift. And model rot is just not keeping up with the new data. Like your prediction becomes less accurate based on the information that we have. So to avoid model rot, you'd need to train your program with new data every time, and that is what you would use online learning for. The final classification of machine learning is instance-based versus model-based learning. This is dependent on how predictions are generalized. So generalization means how it makes predictions on data it has never seen before. So just to compare, this is referring to real world data versus what we already had in our training set. So whatever is outside of the training set is what generalization is used for. So what is instance-based learning? Instance-based learning finds measures of similarity, so let's say the number of words between what was in the training set and the input data, or the number of vowels, or a certain color in an image. So it finds that measure of similarity between the training data samples and the input data, and it determines its prediction based on how similar they are. So the higher the similarity, the more likely the machine learning program is to predict positively. Model-based learning, on the other hand, creates a model, and I've put that in speech marks just to differentiate from our previous definition of model. Here, a model just refers to the shape of the graph. It creates a model based on the training data, and it uses this graph to predict where the input data lies on whatever the shape of the graph is. So I'll cover an example quickly to help you understand model-based learning. Let's say we are trying to find the association between IQ and GPA. So here is our IQ plotted on the x-axis and GPA here. Let's make yellow our training data. So yellow equals training set, and that if your IQ was here, your GPA would be here. If your IQ was here, your GPA would be here. If your IQ was here, your GPA would be here and here. So let's say we had 4 training instances, and that is how they would be plotted on a graph. The machine learning model would look at these points and try to figure out what kind of model to select. So just to go back to our previous slide, the model is the shape of the graph. So you could have a graph that looks like that, you could have a graph that looks like that, or like that, or like that, or something like this, or something like this. Or other examples like this, and so on. This is called, the process of selecting the graph is called model selection. That's another technical term for you. And let's say the model we select is the straight line because it looks like that fits the points the best. So the machine learning model wouldn't draw this line, but it would mathematically figure out this line and then determine the formula for whatever this line is. So for each of these has a different formula. For a straight line or a linear model, the formula is, which you will remember from high school, is y equals mx plus c. Now in machine learning, they have a different convention. So I'll just rearrange this for you for a second. Y equals c plus mx. So this is the same formula we learned in high school. But the machine learning convention is that the Greek letter theta is used instead of these letters here. So you get y equals, theta is 0, which would correspond to the c or the y-intercept, plus theta 1 times x. So again, this would be the y-intercept this would be the gradient, and of course the x and y values are whatever you have been given. So here, our graph, if it's a straight line like this, it would be that GPA, which is the GPA would be the y value equals theta 0 plus theta 1 times IQ. And based on any one of these points or anything on this graph here, it would figure out what theta 0 and theta 1 are. And then all it would need to do is, once it is given the x value, the IQ, let's say it is given 101, it would just have to input IQ in here. And since it will already have these values, it would give you your corresponding GPA, which is the graphical equivalent of just going up like this and coming across like this. And then you would have your corresponding GPA.